Hello everyone, welcome to
Code Crack with Raghu. Today we are going to solve Leetcode 217 contains duplicate problem. In this, here is the problem statement. Uh, Given an integer array nums, return true if any value appears at least twice in the array, else return false if every element is distinct. So here is an example. The input is 1, 2, 3, 1. This array contains duplicates. One is repeated twice. So need to return true uh, according to the problem statement. Okay. If there is one more example, here you can see 1, 2, 3, 4. These are the array elements. All the elements are distinct. So we need to return false. So need to return true or false. If the array contains duplicates, you need to return true, else you need to return false. For this, now we are going to see the approaches to solve this problem. So for this, we have three approaches. First one is brute force approach. We know for brute force, we need to keep two loops because we need to take element 1, element 2, 3, 4. So each element you need to compare and then we need to do the iteration. And one more approach is sort and compare, and one more approach is hash set. So we will analyze the brute force approach first. So in brute force approach, first we need to take a element. Let's say I am taking this element like first element in an array, that is 1. I am going to write a loop. That loop will first take a 1 and the value is 1, and for this value you need to iterate. I need to compare with other values to check this 1 is repeated in the array or not. So I am taking this value, this is the main loop. So we need to keep two loops, right? One is for main and another one is a inner loop. So I am taking one, and for one I need to iterate with all the other elements, right? So that is the inner loop iterations. So for one I take one and I compared with two, and in iteration one, and I compared with three in iteration two, and I compared with four in iteration three. So once all these iterations are complete, we need to see whether the value 1 is repeated or not. So now the value 1 is not repeated anymore because 1 is not equal to 2, 1 is not equal to 3, 1 is not equal to 4. So now we are going to take a second value which is 2. Yeah, this is 2. For this we need to take and you need to compare with the other elements like 3 and 4. So 2 is not equal to 3 and 4. So we need to take a third element 3. We are going to compare with 4. So it is not equal. Then absolutely only 4 is there, so we no need to compare. We will end the loop. So this is the pseudo code. Now I will write the solution how you can do this. So from our understanding, right, we need to write two loops. So this is the main loop. I am writing is I is equal to 0. I is the what is our array nums dot nums dot plus. So one more inner loop we need to keep. That inner loop will be, we need to uh, like j, we can keep j, and that is I plus 1 because we need to start the next element. So we need to go I plus 1, I plus 1 um, plus. And here I am going to write one if loop. This if loop will be having only one condition, that is nums of I equal to nums of j. So here I am just comparing. If the value is present, we are going to return true. If the value is not present, right, what we are going to return, we will return false. That is the default value. So we are going to I execute this now. I will keep a brute force approach B. I will keep short form. So I will add this function and I will check. I'm checking here. So it is false because all the elements are distinct. So we are adding a duplicate element now here, and we'll check. Now it is returning true. So our brute force approach is working, but here we are using two loops, right? One is an order of n and another loop is for order of n. So the time complexity will be order of n power 2. So our time complexity is order of n power 2 and space will be order of n. We are not using any other uh, algorithms here. So it will be coming like order of 1 and time complexity is order of n power 2. Now we are going for a second approach, sort and compare. Here what we will do now, first we have the input, right? 1 2 3 1. We will sort this array. Like once we sort, right, it will go in this form 1 1 2 3 because ascending order it will sort. So the 1 will be moved here and 2 3 will be here. So from this, after the sorting done, right, need to check the adjacent elements. For example, 1 we are taking in the first iteration, it is going to check with the adjacent element. The adjacent of 1 is this one, and so here itself we will found the answer. But this input will be like very easy to find. But in some, let's say we are having two times, right? Then it will be 1 comma 2 comma 2 comma 3. So at the time it will go to one more iteration also. So we need to sort and we need to do a and we need to check the repeated duplicates, so repeated elements. So let's say I'm writing a code for this one, the same only, like same approach. You need to keep first element and you need to check with the adjacent. So if it is present, we need to return true, else now we need to go for the next iteration. So here we are going to follow only uh, one iteration, which will be like one loop, which will be taking the iteration of all the elements. Let's say I'm writing the code for this one, sort okay. I'm writing like this. So I'm writing a pseudo code for this one. Here I am having only one loop. So before that we need to sort, right? So I'm doing the sorting of that nums array. So I will keep a sorted nums array. Okay, so I'm sorting the array now. So I'm sorting the array. So this is a sorted array. Now I am going to compare this sorted array. Okay, sorted array dot length, then I plus plus. We don't need to find the last element. So I am keeping as length minus 1. So now you need to write the same comparison logic. One is nums of I. This is I, and nums of I plus 1. So if it is present, return true, else means by default it will be false. So I'm printing this function now. So this will be sort and compare. So I'm keeping as SC and I'm typing this one. Okay. So you can see, right, both are giving the same output. So now this one is present, so it is returning true. We are going to keep only one loop. So what is our time complexity now here? Our time complexity will be order of n, and order of n for sorting, and one more loop is also we are doing. So it will be order of a log n log n log n. So one loop here, sort. So after sorting we are doing a looping here, so it will be n log n. um, and the space complexity will be no specific things we are using, so we will be keeping order of 1. Okay. Now we are going for the, this is space and time complexity of sort and compare. Now we are going for the hash set. Okay. In the hash set, how we are implementing this hash set approach here now, we have 1 2 3 1, these are the inputs. So I am taking the hash set and first iteration, right? Like only one iteration only here we are going to do, not like brute force two iterations. So only one, in this, not like two loops, it is a single loop. Okay. Single loop, and first element it will take is 1. And here what we need to check now, first to check whether the hash set has this value or not. So the first value, right? So initially the hash set is empty, so we will add the value to the hash set. In the second iteration, we will check whether this 2 is already present in the hash set or not. So already 1 only present, like hash set has value 1, so 2 is not present, so we will add this value 2 also to the hash set. Then in the third iteration we will take 3 and check whether the 3 is present in the hash set. Now what are the values in the hash set? 1 and 2. 3 is not in the hash set. Now we are going to add this value 3 also to the hash set. In the fourth iteration we are going to check with the number 1. Okay, 1 I am going to take a number 1 and check whether the 1 is already present in the hash set. Now in the hash set we already have the number 1, so uh, we are going to return as a true. So what we are going to do now, we are iterating on array, and we are, if the element is present in the array, we are going to return as true. If the element is present in the hash set, we are returning as true. If the element is not present in the hash set, you are just adding that value to the hash set. So this is the logic here. So I am going to write a code for this one also. Set approach. uh, okay, here, that whatever the thing I am saying, right, the same I am going to write here. One is has set. I'm adding the set here, and I'm going to iterate the uh, array. Okay. So same, nums array, we are having the array, right? We are going to iterate element by element, and we are going to compare with the whether the element is present in the hash set or not. That is the logic. Okay. Nums of nums dot length, and one more thing, I plus plus. So what we are going to do here now, only one condition, we need to check whether the value is present in the set or not. So hash will check whether the value is present or not. So nums of I. So if this is present, you are going to do, you are going to return true. So you are going to return true, else no, like the default value, else no, default value false. um, okay, fine. Now we are going to print the value. Has set approach, so I just add set approach SCA, and I'm going to print this. Okay, has set approach. Okay, fine. Okay, you are seeing, right, I missed the main logic. If if the set is there or not, we are returning true, else now we need to add it to the hash set, right? That part I missed. Set dot add of nums of I. Now you can see, right, I implemented the logic exactly. Now it will, you can see all are true. So what I am doing here now, I am taking an element and I am just checking whether the element is present in the set or not. If the element is present, I am just returning true. So if the element is not present in the set, right, I'm just adding that element. So this is the logic, and all are working fine. And we have two examples, right? One is with 1 2 3, one is with 1 2 3 1, 1 2 3 4, two examples. So 1 2 3 1 we checked, and 1 2 3 4 I'm checking now. You can see now all are false, so our solution is fine, our solution is working fine. And we are going to check this solution in the Leetcode also. So we are running the solution, we are running the solution. Then from this, you are seeing, right, the time complexity and space complexity, right? For here, the time complexity will be order of n, and space complexity is order of n, because we are using set here, set, and we are adding the values for every iteration. So it is order of n. Space complexity and time complexity, we are iterating loop, so it is order of n. So both will be order of n. So from this above approach, right, compare and sort and compare, here it will be order of n, order of n log n, time complexity. So compare to these three approaches, right, brute force is order of n power 2. So compare to all these approaches, our hash set is more efficient. And I have added some tabular column. So you can see here, right, what is the thing, how we are comparing, what is the time and space complexity. So I have added approaches here. So these are the approaches, and our approach, like hash set, is some optimal approach, right? For this, we are having time and space complexity as order of n, both will be order of n. So this is a low barrier high signal question, but tells you a lot how you can think, how you can code, and how you can optimize. So this problem we solved, right? This problem is the building block for harder problems, like this longest substring and this robust substring without repeated characters or group anagrams. For those things, right, these are the basic foundation. If you are able to solve this, you are ready for the next level problems also for these problems. And um, yeah, thank you guys, thanks for your time. To yeah, please subscribe, please like, comment and subscribe for more DSA problems. Thank you.